Alright, my name is Devin Lin from Class 11B of Narda Senior High School, and today we will be diving right into integrals. But what is integration? Well, in some ways, integration is the opposite of differentiation. And in other ways, integration can be used to find the area under a curve. Well, let's dive in. Okay, let's start with indefinite integration. So this is what an indefinite integral looks like. The integral of the function f of x with respect to x. So let's say that we define f of x as 6x squared. Well then, the integral of f of x with respect to x will be equal to the integral of 6x squared with respect to x. And one thing to remember about indefinite integrals is that you must remember to add c. Don't forget the plus c. C is called the constant of integration. Now, let's see how to actually evaluate integrals. So on the board, here are two basic rules that you can use to evaluate integrals. The power rule and the chain rule. This is the power rule. So if you have x to the power of n, then the integral of that will be x to the power of n plus 1 divided by n plus 1, and don't forget plus c. So this rule is basically just adding 1 to the power and dividing the result by that new power. Okay, let's look at a quick example. So if you have the integral of x to the power of 2 dx, then it will be equal to x to the power of 2 plus 1 over 2 plus 1. And don't forget plus c. And that will evaluate to x to the power of 3 over 3 plus c. And for more complicated functions, we can use the chain rule. So if we have ax plus b to the power of n, then the integral of that would be ax plus b to the power of n plus 1 over a times n plus 1, and don't forget plus c. Okay, so let's look at another quick example. So if we have the integral of 2x plus 3 to the power of 4, then that will be equal to 2x plus 3 to the power of 4 plus 1 over, we have 2x here, so it's going to be 2 times 4 plus 1, and don't forget plus c. And that will be 2x plus 3 to the power of 5 over 10 plus c. Well, what can we actually do with the rules that we just learned? So let's suppose we have a problem where the derivative of the function f is 6x, and we know the curve passes through the point 1, 5. So how can we find the equation of the curve? So what we can actually do is find the integral of the derivative of f, since integration is the opposite of derivation. So it's the integral of 6x dx. And using the power rule, we can find that the integral of 6x is equal to 6x to the power of 1 plus 1 over 1 plus 1 plus c. And that will go to 6x to the power of 2 over 2 plus c. And we'll end up with 3x to the power of 2 plus c. So now we know that f of x is equal to 3x squared plus c. And how do we find the plus c? Well, we can just plug in the values from the point. The y is 5, and the x is 1, so it's 3 times 1 squared plus c. And with some calculation, we can find that c is equal to 2. So the final answer for f of x is 3x squared plus 2. Now, let's take a look at definite integration. So, this is a definite integral. And you can see that this is different because these have boundaries from a to b. And here we have a graph out here. And if this curve is f of x, then this integral calculates the area under the curve from a to b, this shaded area here. And one thing to note about definite integrals is that there's no plus c. Okay, so here we have a graph of the curve x squared plus 2, and we want to find the shaded area under the curve from 0 to 2. So how can we do this? Well, all we have to do is just to find the definite integral of x squared plus 2 from 0 to 2. Yes. And first, you just integrate this normally. So it will be x to the power 3 over 3 plus 2x. And we have to do it from 0 to 2. And you're going to move this over here. And what this means is that we'll just plug in 2 and minus plugging 0 for x. But since if we plug in 0 for x, it will result in 0. We can just write in 0. And if you plug this into calculator, you will get 20 over 3 units squared. And that's our final answer for this unit area. Well, that's your introduction to integrals, indefinite and definite. Well, I hope you enjoyed that. Thanks for watching.